you so much for that warm welcome and for hosting me here at Innsbruck. And thank you everybody for having me and coming here to this talk. I appreciate it. This work is under review at the journals, and so I'm really curious to hear your feedback and find ways in which this work can be improved. So thank you for thinking about it from that lens. I'll be taking notes as I go as well. This is joint work with my friend and co-author Mesam. He is now a assistant professor in Vancouver at the Simon Fraser University, and we've been. He works on piracy. That was part of his thesis as well, and we've been discussing different ideas as to why is it that piracy is so prevalent, even though the policymaker has been quite interested in tamping down on piracy, especially in the US. You can see, when you get the movie pops up and the screen says that do not pirate this content, etc. Otherwise, you'll end up with a fine of $5,000 and imprisonment for 6 months. And there is, in fact, efforts by the government to try to follow through. It's still, our papers do show that it's not had as much of an effect as they would like. So piracy has been growing. COVID came along and people moved to the digital world en masse at that point of time, and piracy took off. Since COVID as well, these piracy numbers have stayed pretty high. It's relevant, therefore, to different parts of the world. But of course, we know that piracy rates are different in different parts of the world, in different geographies. We'll have some parameters that kind of represent that aspect. But there are problems with depending entirely on the policymaker for anti-piracy efforts. And the problems are twofold. First of all, not all policymakers are equally interested in fighting piracy, in fact. And there are some policymakers who come from jurisdictions where there is a lot of content being produced, and they are therefore more incented to protect those content producers. And then there are others who come from jurisdictions where there's a lot of consumption, but not a lot of production, and so they don't care as much about fighting piracy. So there's some prior work on that front. But also in jurisdictions where there has been effort, and there has been, for instance, the US and California, where Hollywood exists, and they do depend a lot on these incomes. We know that these efforts have not been very successful. So there are some reasons for this, and one of the reasons is that the policymaker alone, through these little screenshots that they're putting up, or their idea to tamp down on piracy, is just not enough. They need some collaboration. In fact, they need the ISP, the Internet Service Provider, or in our case, we call them network providers or NPs. They need cooperation by these NPs. They need the NPs to report to the FBI that this particular person is distributing illegal content, this particular person is consuming illegal content, and then there can be action taken. In fact, US law requires that if the NP knows that there is piracy, that they report these users to the FBI. But then specifically the US does not require that NPs invest in anti-piracy enforcement. So you see that the issue here is that these NPs are going to hang back and relax and not invest, because if they invest, there are two negative effects. There are two incentive incompatibilities for the NP. The first is that 24% of the NP's revenues come from or 24% of network data that's flowing is pirated network data, which represents a lot of revenues that the NP is earning from pirates. If they increase their anti-piracy enforcements, then they're going to lose these consumers who are pirates to some other competitor, and so it's a loss of revenue. The second incompatibility is the enforcement cost there are costs related to technology, related to energy, labor costs, legal costs, etc., of increasing enforcement and identifying perpetrators, which these costs do not serve the NP. Right? So there's no reason for this NP to invest actively, and so simultaneously, there are technologies that exist. Sorry, just take that. Simultaneously, there are technologies that exist that can identify a particular CP-specific content that is being pirated. That is, the NP is able to identify on their network traffic that is being pirated specific to, say, Netflix or specific to Amazon Prime, etc. Now, that's where our idea comes from. Our goal is to evaluate a mechanism where a CP, a content provider like Netflix, etc., can share a proportion of its revenue with the NP, thereby changing the incentives of the NP. This may result in the NP being more interested in the financial well-being of the content provider, and in turn, therefore, increase its anti-piracy enforcement. Right? And so our research questions are as follows. First, will this approach work? Under what conditions or circumstances will this actually happen? Secondly, what is that optimal fraction of revenue that the CP should share? Thirdly, is this good in net for society? And finally, these outcomes, including social welfare, consumer welfare, producer welfare, the extent of piracy that is happening in the market, how do those outcomes from revenue sharing compare against a benchmark where there is no revenue sharing, like our current status quo? And how does it compare against another kind of a benchmark where, let's say, that this content provider and the network provider are vertically integrated to create one firm, which is kind of just a theoretical gold standard where there is no incentive incompatibility between the two. Now they are the same firm. So now how does RS or revenue sharing compare against a vertically integrated firm? Right? So these are our broad research questions, and we come from there's a line stream of research on piracy. This has been an important stream of research since the dawn of the internet, say 1998 or so, the first papers. But there's papers about the negative impact of piracy on the content provider profits. As you might imagine, these content providers do suffer as a result of piracy. There's anti-piracy interventions, such as those by the policymaker, including fines, including enforcement through their power of fiat, through their police and FBI and so forth. And anti-piracy enforcement in terms of taxes on those who are producing materials required in order to counterfeit, or subsidies for those who are consuming legal content. These are all different approaches that have been looked at. There's a work on policymaker incentives, and like I mentioned earlier, some policymakers are interested in anti-piracy enforcement. It's important to their constituency, and for other policymakers, it's just not. There's plenty of work about CP-NP interactions, where, for instance, net neutrality is a field where the policymaker decides whether to enforce net neutrality or not, and then an NP decides whether to offer a fast lane and charge more for a fast lane, and then there is simultaneously they offer a kind of the open internet, and then there's content providers who will decide whether to go with this fast lane or with the slow lane, right? So there's this kind of a set of papers that look at whether net neutrality or not, what are the effects. There's other work in terms of content sponsorship. For instance, Facebook in India provides people with free internet access if they use Facebook. why would they be doing that, and what do they have to gain, etc. So that's content sponsorship. The opposite of that also occurs in other parts of the world, where a ISP sponsors content and says that if you come to my network, then Netflix is free for you. So there's these kind of relationships between CPs and NPs, plenty of work on that. And finally, the agency model, which is about revenue sharing. And this traditionally in manufacturing industries, you get the wholesale model where a manufacturer sells product to a reseller or a retailer, and the retailer sets the price and sells to end consumers. Whereas in modern, some modern settings, you have a manufacturer that lists their product on Amazon, but sets the price for the end consumer. Amazon takes a 10% cut of revenues. So that's an agency model where a percentage of revenues is taken by a different player. Now, of course, so we will, most of these papers that I cited are analytical models, and so we'll list out some of the assumptions that we make. These assumptions here are fairly standard in our literature related to piracy, as far as analytical models are concerned. So I'll go through those quickly. So firstly, we take that potential users of the content are uniformly distributed based on their valuation for the content. That is, some users value the content, this particular content, highly, other users do not. And this valuation is distributed along the line from 0 to 1. Secondly, we assume that the quality of pirated content is valued at beta V, where this beta is a fraction between 0 and 1, which means that this pirated content is of lower quality or provides lower value than the legal content. And these, there's plenty of reasons for it. For instance, there are search costs. You can't just go to Netflix and watch it. You want to go to BitTorrent and then go to some other website, search, get advertisements, you get intercepts. So there are plenty of reasons why when you're online gaming using pirated games, then some features are disabled. You can't play online. You got to play whatever in person, etc. Plenty of reasons why beta is between 0 and 1. And then our third assumption is about enforcement costs, which are increasing and convex in the extent of enforcement. That is, as there is more enforcement, the cost of enforcement increases. And the shape is increasing, because what these enforcers will do is they will try to use the cheapest method of enforcement first. So that's a low cost. Then they are going to use the next most expensive method of enforcement. That's a higher cost, and then the next most, and so forth. Right? So you go for the lowest hanging fruit first before you go for the high hanging fruit. So here we have 4 stages in our analytical model. In the first stage, the CP determines what fraction of its revenue is shared with the ISP, which we denote by the variable S, the share of revenues that the CP is going to share with the NP. In the second stage, the ISP sets its enforcement effort. After observing S, it says, okay, now that you've given me this share, I'm going to set my enforcement effort new. Observing which, the CP now sets the price of its content. And finally, users choose whether to purchase content, whether to pirate the content, or whether to not use the content. So we begin with a benchmark model where there is no revenue sharing, our status quo today, where there is no enforcement, there is no revenue sharing. So it's a simple 2-stage game where prices are set by the content provider, and then users decide whether they want to pirate or use or not use. Okay? So this takes us into the model. So what you see here, I think this, so I can just point at my hand. This is the individual rationality constraint, which says that the users will buy the content if their utility from buying the content is greater than 0. The utility from buying the content is their valuation V of the content minus the data fee that they pay R minus the price for the content. In the benchmark case is PB. So the value minus the prices, if it's greater than 0, that satisfies their individual rationality constraint. Also though, they are going to buy the content if their utility from buying is higher than their utility from pirating. This is their incentive compatibility constraint, which the utility from pirating is beta V minus the data fee. There's no price because it's pirated. So if these two conditions are satisfied, then users are going to buy the content. Now users are going to copy the content on the other hand if their utility from pirating is greater than 0, which is their IR condition, and as well that their utility from pirating is greater than their utility from purchasing the content. Okay. So simple kind of setup where each user along that line, so if you can imagine a valuation of a distribution of consumers or users from 0 through to 1. Some of these do not value the content at all and others value that content extremely highly. Then each user looks at these equations and decides whether they're going to buy, pirate or not use. So what that ends up doing or resolving as two cases. In the first case, let's take the piracy region, which is where some piracy exists. Here, you will get some users between V tilde and 1 pirating, buying the content. Now, why does this happen? The red line represents the utility from buying content, whereas the black line represents utility from pirating. But because of beta, the slope of this black line is less than the slope of the red line. So these two will intersect. And if they intersect within this rectangle, then you will get the piracy region. What happens in the piracy region is from the point of intersection to 1, these users will buy the content. From V underbar to V tilde, you will get users who pirate, and users from 0 to V underbar who will not buy because they are going to get negative utility no matter whether they pirate or they buy. On the other hand, there could be a case where these two lines do not intersect inside the box. They're going to intersect somewhere else, which is where the utility from buying is always higher than the utility from pirating. So in this case, all users will either buy the content or not use the content. This is the no piracy region. So this is a resolution, and what we get at the end of this stage. So just to take a step back, this is a game theoretical model where we use backward induction to reach the Nash equilibrium. So this is a two-stage game. We're going to begin with stage 2 first and then move to stage 1. And in stage 2 is the user's decision. We're going to resolve the user's decision through these equations. And what we end up getting is QL, the quantity of legal users, QC, the quantity of copying users or pirates, and those who do not use it. So the total participation is under V underbar to 1, which is QP in our paper. And those three variables, QL, QC, and QT, will resolve in this stage as a function of the parameters, which are price and data fee. Depending on the price, depending on the data fee, you will get some quantity of legal users and some quantity of pirates. Okay, so that moves us on to stage 1, where the content provider sets the price. Now, setting the price This is classic backward induction, where we've done stage 2, now we're going to stage 1. But the CP knows how the users are going to resolve. If they set a price, then they know how these users will react. So having this knowledge, the CP sets its price. In other words, it's going to maximize its profits by choice of price, where its profits are defined as price multiplied by quantity, and this quantity is a function of its price. Right? And so when you expand this and you replace QL with what we derived in our second state on the previous slide, you'll get an equation here in terms of price and the parameters. And so now you can solve that equation for price, and that gives you what price the CP should set. And so that resolves as follows. I don't want to create an eyesore with getting into these equations, but I just want to let you know that it does resolve. And often these models just don't resolve, so then you're stuck. It does resolve, and it resolves in 3 different pieces. So we call it a piecewise resolution, where in the first piece is where if the data fee is low, then you do have piracy. We end up in the piracy region, and this is the price that is set, 1 minus beta by 2. Whereas if the data fee is a little bit higher in these 2 regions, then you get no piracy. And of course, this is the benchmark without any revenue sharing. We are interested in the world where there is some piracy, and we're trying to use revenue sharing to resolve piracy. So for us, this is the interesting case that we will benchmark against, right? So there is a world with piracy. So this is the benchmark. Now we can talk about revenue sharing. So revenue sharing has 4 stages, like I mentioned. There is first the CP chooses S, then the NP chooses mu, then the CP chooses price, and finally users resolve. Now, so backward induction, we're going to begin with stage 4, where the users are going to resolve. Now, the equations are very similar to what we saw earlier, except for a couple of key differences, or in fact, one key difference, which is the variable mu, which is that there will be some enforcement which is going to reduce the utility for consumers. Right? So we'll need the individual rationality constraint that utility from buying is greater than 0. You're going to need that the utility from buying is greater than the utility from pirating, which consists of beta V, the value that they get from pirating, minus the data fee, minus the enforcement. As the enforcement becomes higher, it becomes more painful for people, more risky for people to pirate. And similarly, the flip side of it resolves into who's going to pirate. So again, legal users, pirates, and total user participation are derived as a function of the parameters and the choice variable. You get QL, QC, everything here as well. And so now you can, in stage 3, the content provider is going to choose its price, and it's going to maximize its profits, which are P times Q, but here it's only going to keep 1 minus S proportion of its profits, because it's sharing S times its profits to the NP. So again, here QL resolves from the previous stage. We know what QL is. You substitute in the stuff and then you optimize, find the optimal value of P, which again resolves very similarly. So I won't get into that. The top one here is where there is piracy, but then there are here, which becomes relevant, other pieces where there will be no piracy if the enforcement is higher. Okay? Low enforcement, there will be some piracy. At higher levels of enforcement, you will not have any piracy. So this is how it resolves. Now, this takes us to our first lemmas, or our kind of minor findings that are required to actually get to our main results. Here in lemma 1, the content price we find is non-decreasing in enforcement, which means that as enforcement is complementary to price, and as enforcement by the NP goes up, then the CP is going to increase its prices. Why? Because the legal market becomes bigger with enforcement. As the legal market becomes bigger, it's an opportunity to increase prices and increase its profits by increasing prices. Lemma 2, enforcement. First of all, if you look at this image, this is the users distributed from 0 to 1, some of which are legal users, others of which are non-users, and in the middle you get some pirates, which is the initial state. But when enforcement goes up, these pirates, the utility that the pirates derive decreases because of enforcement, because of that new. And because of that, first of all, users who are debating whether to pirate or not, they fall on the side of let's not pirate, because now enforcement's gone up, the marginal users are going to drop off. On the other hand, there's users on this right-hand side who are debating about whether to buy a legal copy or whether to pirate. And now with enforcement going up, there is the utility from pirating decreases, and so they might choose to buy a legal version. But there is another piece here, which is we know from lemma 1 that content price increases in enforcement. So these users, while enforcement has gone up, they feel like the utility from pirating has gone down, but also price has gone up. So the total utility from buying has also gone down. But what we find is that the first effect dominates the second, and in net, these users are going to move, this V tilde is going to move to the left. Now, that leads us to stage 2, where the NP or the network provider chooses its enforcement. Here, the network provider's enforcement it's going to maximize its profits by choice of enforcement, where its profit function is in 3 parts. The first is the revenue that it's going to generate from data usage fees. That is, whether they pirate or they use the legal version, they're going to need the internet, and so they're going to pay a data fee R to the NP. Secondly, there's a gain from revenue sharing, which is there's going to be a transfer of funds from the CP to the NP. Thank you, and here's some money. That's gain from revenue sharing. And then there is the cost of enforcement efforts, which, like I mentioned to you, is convex and increasing. So that's the decrease. As you increase your enforcement, you get a negative effect on your profits. So that again resolves in 3 pieces, as you would expect. But I'll kind of map those 2 results using this figure. In the top, there is the no enforcement region, which is where these revenue shares, if they're really low, then setting a positive enforcement does not make any sense for the NP. Because although the revenue share is positive, it is so low that if I increase my enforcement efforts, then the costs of it and the loss of profits, the loss of data fees happening because of pirates running away, that is just too big, and I'm not going to set any enforcement. But there is a middle set of revenue shares where I will set a positive enforcement, and this enforcement actually is increasing in the revenue share. And as you increase the revenue share that you give to me, I will increase my enforcement. There is a third piece, which is a very high revenue share, which is what happens here is that at some point, as these in the middle, the revenue shares keep going up and the enforcement goes up in return, at some point, piracy is eliminated and we fall into the no piracy zone. And so there is no piracy anymore. And now if these revenue shares increase any further, there's no point in this NP increasing its enforcement anymore. So it stops, and you can keep giving me more and more revenue share. I'm not going to increase my enforcement in turn. So here, this is not a function of S. I stop responding to revenue shares. And that is, these three pieces are depicted as 1, 2, and 3, where initially there is no response to revenue shares. Later on, there is some response to revenue shares, and my profits, the NP's profits from setting a positive enforcement in blue are higher than my profits from setting 0 enforcement in black. Once I have reached the no piracy zone, my profits from not further increasing my mu are highest and they are in red. Whereas if I start responding, or if I set 0 enforcement, then my profits are going to be lower. So those are the three zones depicted over here. Now that takes us to our final stage, stage 1, where the CP is going to set its revenue share. So here it knows how the NP is going to react to its revenue share. It knows how the price is going to be set, and it knows how users are going to react. And so with all this knowledge, it's going to set its revenue share S by maximizing its profit, which is P times Q times 1 minus S, like we saw earlier. And that again resolves in those in the three equations, which here resolves in 3 regions. There is this region in the dark shade at the bottom. So on the x-axis is the data fee R, on y-axis is enforcement cost C. There's this region with low data fee and low enforcement cost, where with revenue sharing, piracy will be eliminated. This is with the optimal revenue share F star, piracy will be eliminated. There is this portion in light shade, where with revenue share, the optimal revenue share, piracy will be reduced but not eliminated. And then there is this region in white, which is the no revenue sharing region, where we will not have, revenue sharing cannot profitably happen. Right? So because of the lack of time, I won't get into what the implications are, but there are some regions in the world which have high data fees. Canada is a great example. Where I come from, it's about $65 a month on average. There are other regions in the world where it is much cheaper. So for instance, China is at about $19 on average, and India is even cheaper at about $10 on average. So you can see which regions might, what might happen in different regions. As well, enforcement cost is a technology perspective. That is, you might have over time the technology required to identify pirates, to analyze data, to report these in real time might become cheaper. So you might have over time a reduction in technology costs in order to make this happen. So it gives you some perspective of the implication. So this leads us to our propositions. I think I can have 5 minutes more. Sure. Okay. Thanks. So in our first proposition, we are going to perform some comparative statics on the optimal revenue share S star and see how this S star changes with enforcement cost, how it changes with the data fee, and how it changes with the quality of content, pirated content. And we can see that these are really different in each of the no piracy regions and the piracy regions. And there are some reasons for it. Primarily, you have this no piracy region, which is a corner solution really in our model. Here, the CP shares an S star that will eliminate piracy and not anymore. And so when the enforcement cost goes up, for instance, it's going to have to share more so that the NP can eliminate piracy. So that's why you see that in the piracy region, you actually have change in the revenue share. Whereas in the no piracy region, it's a different optimum. It's just a different optimum. So the comparative statics are different. So now we move on to something called the revenue sharing region, which is the parameter space or the universe within which revenue sharing can indeed successfully happen. That, like we mentioned earlier, is this region. The whole shaded region is the revenue sharing region. This is the region without piracy, and this is the region with piracy, which resolves into these three integrals: area under the curves. And performing some comparative statics, we can come up with our second proposition that this revenue sharing region expands with the quality of the pirated content. It contracts with the data fee and the enforcement cost. And it tells you what are the geographies in the world, what are the technological progress in terms of what is the effect of technological progress on the likelihood that revenue sharing will happen. Tells you a little bit about the quality of pirated content. There are some content providers like book publishers whose pirated content is really high. You get a pirated book, you can't hardly tell the difference between a pirated book and a legal book. Whereas with games, you can the quality of pirated content often is very low, and it's also CP specific. So again, it tells you who is this appropriate for and who not. Finally, we go into the benchmark comparison, which is how does revenue sharing compare against vertical integration, where the CP and the NP integrate into a single firm. And in this case, there is no incentive incompatibility. They care each other, they love each other, they want each other to succeed. All they care about is total joint profits. So in this case, the integrated firm sets the content price and the level of enforcement together. Users decide whether to purchase, to pirate, or to not use. And so here, the profit function is you get the price times the quantity plus from the legal content, plus the data fee from the legal users as well as the pirates, minus the enforcement cost. And here, this integrated firm is going to maximize that equation, their profits, by choice of both price as well as you. So that leads us to proposition 3, which is that under vertical integration, the enforcement effect is positive throughout the parameter space. To say this differently, what is this enforcement effect? Is we define enforcement effect as the increase in profits. So the profits of this integrated firm is always increasing because of this integration. If it was unintegrated or disintegrated, the profits would be lower. But that is because this integrated firm will always set positive enforcement. Because of that, they care about each other. There will always be positive enforcement. And the revenue sharing mechanism brings us closer to that situation where they care for each other. Thirdly, the optimal content price and enforcement under vertical integration are higher than those under revenue sharing. So what you will end up seeing is the prices under vertical integration will be higher. As an end consumer, you do care about prices, and our population, our consumer surplus care about prices. Vertical integration will lead to a higher price than RS or revenue sharing. Which leads us to our last two propositions. And this lemma is required for these propositions. Compared to the benchmark, revenue sharing, benchmark is where there is no revenue sharing. It's prior to any revenue sharing. That compared to the benchmark, that revenue sharing can yield a higher legal surplus. Now, legal surplus is defined as legal user surplus plus the profits of the NP plus the profits of the CP. That is legal surplus. Social surplus also includes the surplus of the pirates. And our review team basically asked us to look at legal surplus and not at social surplus, and so that's where we're at. So here we have proposition 4, that under revenue sharing, the CP, the NP, and the legal users are all better off compared to the benchmarks, with low data fees. So if there are low data fees, then all the parties are better off. Surely then the sum legal surplus is higher under RS. And our final proposition, if the enforcement cost is low, such that both RS and VI yield the no piracy region, so if there is no piracy, then legal surplus is strictly higher under revenue sharing. Legal surplus, in fact, higher under revenue sharing than under vertical integration. The reason this happens is because when the firms are vertically integrated, the incentives between the two firms disappear. They care for each other a lot and they make joint decisions, they communicate with each other, collude with each other. The end result being that prices become really high. And when prices are really high, consumer surplus drops, legal user surplus drops. And so under vertical integration, the legal surplus may be lower than under revenue sharing. And in part B, if the enforcement cost, this basically says that there are other conditions as well, apart from this particular condition that we stated. There are other conditions as well under which the legal surplus is higher under RS than under VI. So, in conclusion, RS can indeed successfully occur, and when we say RS can successfully occur, we mean it can occur in a way such that the CP and the NP are both better off, but that's only then will they be interested in doing this. That there are specific markets and time frames where RS can successfully occur, and we've identified those. And if the data fees are low, then all parties can be better off under RS. And then finally, under some conditions of low enforcement and or low data fees, the legal surplus can be higher under RS than under vertical integration. So with that, thank you very much for listening.